Hello everyone and welcome back to the channel. I am so happy to see you here today. If you're new to this channel, please take a moment to subscribe. Click that subscribe button and hit the notification bell so you do not miss any of our upcoming lessons. If you find this video helpful, please give it a like. It really helps us to reach more students who need this kind of support. Also, I want to hear from you. If you have any problems or topics you're struggling with, please comment down below. I read every single comment, and for those of you who have personal questions or need one-on-one help, I will put my WhatsApp line below the video in the description box. Feel free to message me there. I am here to help you succeed. Today, we are going to learn about a topic that is fundamental to further mathematics and additional mathematics. We are going to talk about sequence and series. This lesson is suitable for SHS1 and SHS2 students. Now, I know that when you hear the words sequence or series, you might feel a little nervous. Many students find this topic challenging because there are many formulas and rules to remember, but I want you to relax. We are going to take this very slowly. We are not going to rush. We will break everything down into small, easy pieces. By the end of this video, you will understand exactly how to handle these problems. We have about 3 periods worth of content here, which is 120 minutes. So we have plenty of time to explore this deeply. I want this narration to be about 35 to 40 minutes long so that you have enough time to digest every single step. So grab your notebook, get your pen ready, and let us begin. Let us look at what we want to achieve by the end of this lesson. These are our learning objectives. By the time we finish, you should be able to distinguish between a sequence and a series. You will learn how to identify and solve problems involving arithmetic progression. You will learn how to identify and solve problems involving geometric progression. You will learn how to calculate the sum to infinity of a geometric series. You will learn to represent series. And finally, you will learn how to apply progressions to real-life situations like savings, depreciation, and recurring decimals. That is a lot, but we will take it one piece at a time. Let us start with Section 2, Introduction to Sequences and Series. First, what is a sequence? A sequence is an ordered list of numbers following a specific pattern. Think of it like a queue of people. The order matters. For example, if I say 2, 4, 6, 8, so on, that is a sequence. Each number increases by 2. Next, what is a series? A series is the sum of the terms of a sequence. So if I take that sequence 2, 4, 6, 8, and I add them up, like 2 plus 4 plus 6 plus 8, that is a series. We are adding them together. Each number in the sequence is called a term. We label them. The first number is the first term. We write this as t sub 1. The second number is the second term, written as t sub 2. The nth number is the nth term, written as t sub n. This n just means any number position. There are 2 main types of progressions we will study. Number 1 is arithmetic progression, often called a p. This is where there is a constant difference between terms. Number 2 is geometric progression, often called GP. This is where there is a constant ratio between terms. We will look at each one carefully. Now let us move to Section 3, Arithmetic Progression. What is an arithmetic progression? An AP is a sequence where the difference between consecutive terms is constant. This difference is called the common difference. We use the letter D for this. To find D, you take any term and subtract the term before it. So D equals T sub n minus T sub n minus 1. For example, in the sequence 2, 5, 8, the difference is 5 minus 2, which is 3, and 8 minus 5 is also 3. So the common difference is 3. There are key formulas you must know. I want you to write these down clearly. Let it be the first term. Let D be the common difference. Let n be the number of terms. The first formula is for the nth term. T sub n equals a plus open bracket n minus 1 close bracket multiplied by d. This tells you what any specific term is without listing them all. The second formula is for the sum of n terms. S sub n equals n over 2 multiplied by open bracket 2a plus open bracket n minus 1 close bracket multiplied by d close bracket. This tells you the total if you add up the first n numbers. There is also a third formula for sum using the last term. S sub n equals n over 2 multiplied by open bracket a plus l close bracket, where l is the last term, which is t sub n. Use this one if you know the last number in the list. Let us look at example 1, finding the nth term. The question is, find the 20th term of the sequence. 5, 9, 13, 17, and so on. Step 1. Identify A and D. The first number is 5, so A equals 5. To find D, subtract the first from the second. 9 minus 5 equals 4, so D equals 4. Step 2. Use the T sub n formula with n equals 20. The formula is T sub n equals A plus open bracket, n minus 1, close bracket multiplied by D. Substitute the values. A sub 20 equals 5 plus open bracket 20 minus 1 close bracket multiplied by 4. Let us calculate inside the bracket first. 20 minus 1 is 19, so now we have 5 plus 19 multiplied by 4. Multiplication comes before addition. 19 multiplied by 4. Let us do this slowly. 10 times 4 is 40. 9 times 4 is 36. 40 plus 36 is 76. So now we have 5 plus 76. 5 plus 76 is 81. Answer. The 20th term is 81. Please write that down. See how we just followed the formula step by step. Now, let us look at example 2, finding sum of terms. The question is, find the sum of the first 15 terms of the AP. 2, 5, 8, and so on. Step 1, identify A, D, and N. The first number is 2, so A equals 2. The difference is 5 minus 2, which is 3. So D equals 3. We want the first 15 terms. So N equals 15. Step 2. Use the S sub n formula. The formula is S sub n equals n over 2 multiplied by open bracket 2a plus open bracket n minus 1 close bracket multiplied by d close bracket. Substitute the values. S sub 15 equals 15 over 2 multiplied by open bracket 2 times 2 plus open bracket 15 minus 1 close bracket multiplied by 3 close bracket. Let us calculate inside the big bracket first. 2 times 2 is 4, 15 minus 1 is 14. So now we have open bracket 4 plus 14 multiplied by 3, close bracket. 14 multiplied by 3. 10 times 3 is 30. 4 times 3 is 12. 30 plus 12 is 42. So now we have open bracket 4 plus 42, close bracket. 4 plus 42 is 46. So the equation is now S sub 15 equals 15 over 2 multiplied by 46. We can divide 46 by 2 first. 46 divided by 2 is 23. So now we have 15 multiplied by 23. Let us calculate this. 15 times 20 is 300. 15 times 3 is 45. 300 plus 45 is 345. Answer. The sum is 345. Take your time with the arithmetic. It is easy to make small mistakes there. Now let us look at example 3, solving for a day and D using simultaneous equations. This is a common exam question. The question is, the third term of an AP is 11, and the seventh term is 23. Find the first term and common difference. Step 1, write equations using the T sub n formula. The formula is T sub n equals A plus open bracket n minus 1 close bracket multiplied by D. For the third term, n is 3. So n minus 1 is 2. So T sub 3 equals A plus 2D. We are told this equals 11. So equation 1 is a plus 2d equals 11. For the seventh term, n is 7. So n minus 1 is 6. So t sub 7 equals a plus 6d. We are told this equals 23. So equation 2 is a plus 6d equals 23. Step 2, subtract equation 1 from equation 2. We have a plus 6d minus open bracket, a plus 2d close bracket equals 23 minus 11. The a minus it cancels out. 6d minus 2d is 4d. 23 minus 11 is 12. So we have 4d equals 12. Divide by 4. D equals 3. Step 3. Substitute d into equation 1. We have a plus 2 times 3 equals 11. 2 times 3 is 6. So a plus 6 equals 11. Subtract 6 from both sides. A equals 5. Answer. First term mods a equals 5. Common difference d equals 3. This method works for any two terms given. Just set up the two equations and solve. Now let us move to section 4. Geometric progression. What is a geometric progression? A GP is a sequence where the ratio between consecutive terms is constant. This ratio is called the common ratio. We use the letter r for this. To find r, you divide any term by the term before it. So, r equals t sub n divided by t sub n minus 1. For example, in the sequence 3, 6, 12, the ratio is 6 divided by 3, which is 2, and 12 divided by 6 is also 2. So the common ratio is 2. There are key formulas for GP as well. Let it be the first term. Let r be the common ratio. Let n be the number of terms. The first formula is for the nth term. T sub n equals a multiplied by r to the power of open bracket n minus 1 close bracket. Notice the power is n minus 1, not n. This is a common mistake. The second formula is for the sum of n terms. If r is greater than 1, use s sub n equals a multiplied by open bracket r to the power of n minus 1 close bracket divided by open bracket r minus 1 close bracket. If r is less than 1, use s sub n multiplied by open bracket 1 minus r to the power of n close bracket divided by open bracket 1 minus r close bracket. Both work, but these forms keep numbers positive. The third formula is for sum to infinity. S sub infinity equals a divided by open bracket 1 minus r close bracket. But there is a very important condition. This formula only works if the absolute value of r is less than 1. This means r must be between -1 and +1. If r is bigger than 1, the sum goes to infinity and does not exist. Let us look at example 4. Finding the nth term. The question is, find the sixth term of the GP 3, 6, 12, 24, and so on. Step 1. Identify a and r. The first number is 3, so a equals 3. The ratio is 6 divided by 3, which is 2. So r equals 2. Step 2. Use the t sub n formula with n equals 6. The formula is t sub n equals a multiplied by r to the power of open bracket n minus 1 close bracket. Substitute the values. T sub 6 equals 3 multiplied by 2 to the power of open bracket 6 minus 1 close bracket. 6 minus 1 is 5, so t sub 6 equals 3 multiplied by 2 to the power of 5. What is 2 to the power of 5? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So t sub 6 equals 3 multiplied by 32. 3 times 30 is 90. 3 times 2 is 6. 90 plus 6 is 96. Answer, the sixth term is 96. Remember to calculate the power before multiplying by a. Now, let us look at example 5. Sum to infinity. The question is, find the sum to infinity of the series. 18 plus 6 plus 2 plus, and so on. Step 1. Identify A, and Step 3. Use the S sub infinity formula. The formula is S sub infinity equals a divided by open bracket 1 minus R close bracket. Substitute the values. S sub infinity equals 18 divided by open bracket 1 minus 1 over 3 close bracket. 1 minus 1 over 3 is 2 over 3. So S sub infinity equals 18 divided by 2 over 3. Dividing by a fraction is the same as multiplying by its reciprocal. So 18 multiplied by 3 over 2. 18 divided by 2 is 9. 9 multiplied by 3 is 27. Answer: the sum to infinity is 27. This means if you keep adding these numbers forever, the total gets closer and closer to 27. Now let us look at example 6, recurring decimals to fractions. This is a very useful application. The question is, express 0.36 recurring as a fraction in simplest form. This means 0.363636 and so on. Step 1. Write as a sum. 0.36 recurring is equal to 0.36 plus 0.0036 plus 0.00036 and so on. Step 2. Identify GP parameters. The first term, A, is 0.36. This is 36 over 100. The ratio R is 0.01. This is 1 over 100. Each term is getting smaller, so R is less than 1. Step 3. Use S sub infinity formula. S sub infinity equals a divided by open bracket 1 minus R close bracket. Substitute the values. S sub infinity equals open bracket 36 over 100 close bracket divided by open bracket 1 minus 1 over 100 close bracket. 1 minus 1 over 100 is 99 over 100. So we have open bracket 36 over 100 close bracket divided by open bracket 99 over 100 close bracket. The 100s cancel out, so we are left with 36 over 99. Step 4. Simplify. Both numbers can be divided by 9. 36 divided by 9 is 4. 99 divided by 9 is 11, so the fraction is 4 over 11. Answer: 0.36 recurring equals 4 over 11. This is a standard trick for converting recurring decimals. Now let us move to section 5, sigma notation. Sigma notation is a compact way to represent the sum of a series. The symbol is the Greek letter sigma, which looks like an E lying on its side. It is written as sigma with R equals 1 at the bottom and at the top. This means sum from term 1 to term n. Let us look at example 7, expanding sigma notation. The question is, evaluate sigma from k equals 1 to 4 of open bracket 2k plus 1, close bracket. Step 1, substitute values of k from 1 to 4. When k equals 1, 2 times 1 plus 1 equals 3. When k equals 2, 2 times 2 plus 1 equals 5. When k equals 3, 2 times 3 plus 1 equals 7. When k equals 4, 2 times 4 plus 1 equals 9. Step 2, sum the results. We add them up. 3 plus 5 plus 7 plus 9. 3 plus 5 is 8. 7 plus 9 is 16. 8 plus 16 is 24. Answer: 24. This is just a fancy way of saying add these four numbers. Now let us look at example 8. Sum of an AP using sigma. The question is, evaluate sigma from R equals 1 to 10 of open bracket 3, R minus 2, close bracket. Step 1, identify it as an AP. Find the first term by putting R equals 1. 3 times 1 minus 2 equals 1, so A equals 1. Find the last term by putting R equals 10. 3 times 10 minus 2 equals 28. So L equals 28. The number of terms n is 10. because r goes from 1 to 10. Step 2. Use the S sub n formula for AP. The formula is S sub n equals n over 2, multiplied by open bracket, a plus L close bracket. Substitute the values. S sub 10 equals 10 over 2 multiplied by open bracket, 1 plus 28, close bracket. 10 over 2 is 5. 1 plus 28 is 29. So 5 multiplied by 29. 5 times 20 is 100. 5 times 9 is 45. 100 plus 45 is 145. Answer 145. Sigma notation often hides an AP or GP inside. Look for the pattern. Now, I want to warn you about common mistakes students make. Section 6. Mistake number 1. Confusing n and minus 1. Using a multiplied by r to the power of n instead of r to the power of n minus 1 for the nth term of a GP. Correction. Remember, the first term is a times r to the power of 0. So the nth term is n minus 1. Mistake number 2. Sum to infinity condition. Trying to find a sub infinity when r is greater than 1. For example, 2 plus 4 plus 8. Correction. This sum diverges. It does not exist. Only use the formula if r is between -1 and +1. Mistake number 3, AP versus GP, mistaking a constant difference for a constant ratio. Correction. Check by subtracting terms for AP. Check by dividing terms for GP. Mistake number 4. Sigma limits. Confusing the starting value. If it starts at r equals 0, there are more terms than if it starts at r equals 1. Correction. Count the terms carefully. Mistake number 5, negative ratios. Forgetting that were can be negative in a GP. For example, 2, -4, 8. Here r is -2. Correction. Watch the signs when dividing. Now it is time for class evaluation, section 7. I want you to pause the video and solve these in your notebook. Question 1. Find the 10th term of the AP, 7, 10, 13, and so on. Question 2. Calculate the sum of the first 20 natural numbers. That is 1 plus 2 plus 3 up to 20. Question 3. Find the common ratio of the GP, 5, 15, 45, and so on. Question 4. Evaluate the sum to infinity of 16 plus 8 plus 4, and so on. Question 5. Expand and evaluate sigma from a equals 1 to 3 of I squared. Take your time. Write down your steps. Do not rush. I will wait for you for your assignment. Section 8. Please do these at home. Question 1. The 5th term of an AP is 19 and the 10th term is 39. Find the sum of the first 15 terms. Question 2. Find the value of x if x, 2x plus 2, 3x plus 3 are the first 3 terms of a GP. Question 3. Express 0.15 recurring as a fraction in simplest form. Question 4. Evaluate sigma from k equals 1 to 5 of 2 to the power of k. Question 5 is a challenge. A ball is dropped from a height of 10 meters. Each time it bounces, it reaches half the previous height. Calculate the total distance traveled by the ball before it comes to rest. Hint: consider downward and upward movements separately. Dude, man, this last one is tricky. Remember, the ball goes down, then up, then down, then up. The first drop is only once. The bounces are twice. Let us do a summary of what we learned today. Section 9. A sequence is a list of numbers. A series is the sum of numbers. Arithmetic progression has a constant difference. D, the nth term, is a plus open bracket, n minus 1 close bracket. D, the sum is n over 2 times open bracket 2. A plus open bracket, n minus 1 close bracket. D close bracket. Geometric progression has a constant ratio r. The nth term is multiplied by r to the power of n minus 1. The sum to infinity is divided by 1 minus r, but only if r is less than 1. Sigma notation means sum from the bottom number to the top number. Recurring decimals can be converted to fractions using GP sum to infinity. I know this was a long lesson, but you have done amazingly well. Sequence and series can be confusing because of the many formulas, but you now have the tools to handle them. Remember, practice is the key. The more you practice identifying AP and GP, the faster you will become. If you enjoyed this video, please give it a like. It helps the channel grow. If you have not subscribed yet, please subscribe and turn on notifications. I post new lessons regularly. If you have any questions about this lesson, or if there's a specific problem you're stuck on, please comment down below. I try to answer as many as I can. And remember, for personal questions, my WhatsApp line is in the description box below. Do not hesitate to reach out. Thank you for watching. Keep practicing. Stay confident, and I will see you in the next lesson. Goodbye for now.